Hello and welcome back. Have you noticed something new? Well, maybe not new. Basically, game performance suck, and it's getting worse and worse every year. It's gotten to the point where they don't even want you to render the game in full resolution anymore. It used to be 4K, it's the future. Now it's like 720p, it's the future. And then we just upscale it for you so it looks like absolute trash. And it feels like more and more of the modern games are going for this look, which is bizarre. And if you look at a lot of these new games and their recommended settings, the minimum recommended setting is above that of a normal Steam user, for instance. So even then, your PC is just too bad to actually run it. And with the recommended settings, even then, they show settings that don't actually have it full screen. For instance, if you run 1080p, which is full HD, they recommend you only run in basic HD 720p, and then upscale it using their new AI technology with fake frame rate in order to be able to reach a basic frame goal of 30 FPS. So one of the games I used to play a long time ago is Ark, and they made an update. I tried it out, and in the old Ark I used to run for about 100 FPS, maybe even more in some areas, a bit less if there was a lot of dinos. But in the new game, I barely even hit double digits with the fake frames. What's the point of making a graphical update that people can't use? And if we take a look at the Ark, for instance, this is the new Ark. 20,000 people, all-time peak of 98. And this is the old Ark, 23,000 people with 240,000 all-time peak. So basically, a lot of people are stuck here because they don't have a machine capable of running the new Ark. They're splitting the player base, which is a horrible thing to do because you end up with empty servers. So you want all of them to be in one place, if at all possible. And Ark isn't the only game that does this. There's a ton of other games out there that are also just poorly optimized. And for no apparent reason, they just don't function the way they're supposed to. And the great solution that these companies came up with was to just lower your resolution. You have a fancy new monitor, 2K monitor, and they want to run it at 720p and then upscale it. So it looks like a blurry mess with a lot of pixelation. Right? I mean, just a few years ago they were talking about maybe making the 4K a new standard. And then he just threw that out the water because they wanted ray tracing and other weird stuff like that. And one way that they intend to fix this, so they render it in low resolution, they upscale it, then they add temporal FXA on top of it, so that's temporal anti-aliasing, which basically blurs your current frame with previous frames, so you get an extra blurry mess that looks like absolute shit. And in a lot of these games you can't even turn that off, because if you turn it off, it also looks like shit. So now, having looked at a few of these examples, let's talk at why and how we got to this point in the first place. Because it's really, really ridiculous. There's actually a few reasons why we ended up in this place. So the first one is marketing. Back in the olden days, graphical hype was the thing to go for. If your game looked new, it looked awesome, and it had all of the lighting stuff, that was a massive selling point. Nowadays, you can't really tell the difference between two games, especially when they all use the same engine as well. So in order for them to be able to market their lighting, they need to go extreme. We're talking ray tracing, something that our computers are not ready for yet. And the reason that they're still doing this is, well, corporations are very slow. So they haven't realized that they can't do this anymore. It used to work really well 10, 15 or maybe 20 years ago when 3D starts showing up. And oh, screen space ambient occlusion, it looks amazing. We've never seen this before. Global illumination, incredible. Ray tracing, it's amazing. And it also has a massive performance impact that people can't handle because, you know, the graphic cards aren't at that point yet. And a sad thing about this is that a lot of people actually look at a trailer, they see the graphics for it, and then based on that, they will then decide whether or not it's an interesting thing to buy, right? And a lot of these modern trailers, they don't actually show any gameplay. So the only thing you have to go out of is how well it looks. And if people put a lot of effort into making it look good, surely they will do the same with the gameplay. Which, unfortunately, in a lot of cases, simply isn't true anymore. And the whole thing with ray tracing, I find it to be completely pointless. We already have things that are good enough. We have, what's this called? Yeah, we have the screen space reflection, so it just bounces it off where the screen is, and then it checks what has already been rendered, and it uses that for reflection. And if that isn't good enough for you, you can always do a cube map, which is basically similar to shadows. It's a lot cheaper than ray tracing, might not look as good, but it looks pretty good still. Now let's get into the meat of the matter. So if you want to see why things are getting so out of hand, take a look at this one. So this is the Unreal documentation, where they basically have a performance notice for a typical system used at Epic Games. So this is basically what they recommend developers to be utilizing. They are using a processor, AMD Ryzen Teardripper 7985WX, which goes from 3.2 GHz all the way up to 5 GHz. We'll come back and look at that one in a bit. And for the GPU, it's an NVIDIA RTX 4080 with 16 GB of VRAM. So even here we have a problem, right? Because on Steam, the standard is 8 GB. It's what most people have. Now 16 is nice, but if you make it for a 16 GB system and the player only has 8 GB, that means they have to have the memory on RAM, which is a lot slower. And then you're gonna suffer a lot of performance issues because you have to sample it from the RAM every frame, and it's not built for that. So let's go up to the comparison. As you can see right here, this is what they believe the Steam machine will have. So we are comparing the CPU, which is a semi-custom AMD Zen 4, and the GPU as also a custom one, RDNA 3. Now these might not be available for stores. We're looking at something similar to those. And first up we have, here we go, this is the CPU benchmark. We compare the Steam AMD Ryzen 5, that's a similar to what they're planning to have in the Steam machine. Compare that to what it's recommended from the Unreal Engine. And as you can see, the single core processing speed is about the same, but for the multi-core, it's more than 3 times as fast. Now, surely that won't be a difference, right? I mean, if you develop for this and you get used to have that kind of performance, surely that wouldn't result in you spending performance you shouldn't in order for your players to actually have a nice experience playing. And this is the second one. So on the left we have the estimated Steam machine performance, and to the right we have what they recommend on the Unreal Engine, and as you can see, it more than doubles the performance of what the above average Steam user has. So if you're developing with these kinds of things, you shouldn't be surprised if a lot of the people you're developing it for won't be able to run it, unless you do some insane optimization towards the end of the development process. And the thing is that towards the end of the development, most people don't have time to optimize. So one thing that is highly recommended is that if you are a developer and you want to develop for a specific target audience, most likely above 50% mark on Steam users, right? Then you need to make sure that you sit on a similar computer. So if you run into a problem developing it because it starts getting laggy, you know that it's time to start optimizing it, or maybe cut away a few features that are too expensive. But what we end up in a situation like this is that they can't tell that it's unoptimized until they start player testing. And as you might have seen with Fallout and all those games, that usually happens like 3 weeks before it's time to launch. And at that point, you don't have time to optimize it. You can't make any major system changes in order to make them more optimized. So it's a trap having such performance when you're developing it. And while we're at the subject of performance, I can't remember the last time I heard someone actually complaining about the graphics in a game. Maybe Valhalla, but in general, people are pretty okay with graphics as they are. So there's no need to push the ray tracing stuff when it only gives a little bit of a difference in each image. And that difference is something you don't pay that much attention to, right? I mean, I've never actually tried to use the reflection of a water puddle in order to shoot someone, for instance, and it's not a game mechanic that I have been missing. That's all I have to say. So if you're a game developer, please consider what I said about maybe not picking the absolute best computer to work on, and maybe target your target audience a bit more and aim for that kind of computer, so that if they're running into a performance bottleneck, you know that well ahead of time before the launch actually happens of your game. Because while some people might decide to upgrade a PC because there's a video game they have been wanting for a long time showing up, in all likelihood it's not gonna happen. So if your game simply doesn't run on their computer, they simply can't play it until they can afford to upgrade, right? As always, thank you for stopping by and see you some other time.